Welcome to Old School Chemistry. Today we are going to do the ALEKS topic, Distinguishing Accuracy and Precision. Can I just tell you right out of the gate, this is a beast. This is a involved problem. How's that? You will want to have your problem up. I'm not joking. I would have your problem on one computer and then watch this one on your phone and do it with me. Okay, do it at the same time. Now, the one saving grace on this problem is that you will always be given the similar types of numbers. You'll be given one number with a unit, a number that has a standard deviation and a unit, a number with a percent for the standard deviation, and then you'll be given this between two numbers. These will be moved between the A, B, C, D, but you will always have one of those types, and that will really, really help you as you move through this. So as I'm doing it, you want to find your number, not joking, that has just the number and the unit, and treat it the same way that I do. Let's go ahead and read this together. It says, our research teams measured the speed at which signals travel down a certain type of nerve fiber, and what each team wrote in its team notebook is shown below, shown in the table below. So there are always going to be some sort of group of teams that are taking some measurements, okay? Suppose a more reliable measurement gives 29.0 meters per second. Okay, that is going to be your actual. That's the actual value. And every time, every problem, it's going to be a different number, but they will give you one actual value for the signal speed of the same type of nerve fiber. Decide which of the earlier measurements was the most accurate and which was the most precise. Now, accurate, remember, is the one that is closest to the actual value. And when you're given multiple numbers, it's going to be the average, that average, which one's closest to the actual. Excuse me. Precision is all of the data points. How close are those to one another? That's the difference. To be precise, measure thrice. That will help you remember, oh yeah, multiple measurements, how close they are, that's precision. Okay, let's start with accuracy. I actually have my students write two columns. We're going to do A for accuracy and P for precision. On your accuracy, you're going to take every one of these numbers, do it as an absolute value, and subtract it from the actual. We just want to know how far it is from the actual, the number that the researchers should have gotten. So absolute value on this, I'm going to do 29 minus 27 gives me 2. And I'm going to underline that. Okay, there's one number. Then I'm going to take my 28, actually I'll do it consistent. We'll take the 29 minus 28, and that gives me 1. That was my A, here's my B, let's do C. Absolute value, 29 minus 30. Remember, absolute value is going to give me 1. And then here on this one, you have to take the average. So I'm going to add those and divide it by 2. Okay, add those and divide it by 2. I'll do that right over here. So I have 28.7 plus 28.9. Divide that by 2, and we get 28.8. That's the number that I use over here for part D. So D, I have 29, again, my absolute value, minus 28.8, and I get 0.2. The most accurate is the smallest number. This smallest number tells me that their value was closest to the actual. So on this, right there, let's mark that. It's going to be D. D was the most accurate. Okay, good. I'm going to erase this, and now let's do the precision. The precision is definitely more involved. Okay, so on our precision, I'm going to pull this up here, precision. And like I said, for my students, I just have them do another column that says P for precision. When you have just one number, the way we find the standard deviation, and that's going to be, in essence, a measure of how close all of the data points are together, what you do is you take the last placeholder, the last value, don't say placeholder, the last value, and you make it a 1. So if this is 27, That means it's plus or minus 1. Now, I want to give you some examples on this. Let's say that you had 27.0. That'd be plus or minus, watch this, 0.1, because that 0 is at the tenths place. Let's pretend that you had 27.05 or 03. This would be plus or minus 0.01 because that's at the hundredths place. Let's do it one more time. Let's say that I had, I'll put it down here. Let's say that I had 27.035. Can you think, what's the plus or minus? What's the standard deviation going to be on that? Plus or minus 0.001 down to the thousandths place because the last value is at the thousandths place. So this one, our last value is at the ones place. So it's going to be plus or minus 1. That's how you do standard deviation when you have just a number. Now this one is the only easy thing in this whole problem. When you have a number plus or minus a value with a unit, that's your precision. Done. All I have to do is write down 0.2. Okay, so I have the 1 and I have the 0.2. There's my A and there is my B. Okay, on this one, a little bit of work. You're going to convert percent to decimal and then multiply. Let me write this down for you. So on C is going to be 30 times my 2% divided by 100. And remember, I do the converting from percent to a decimal, just divide by 100. So we'll take our percentage, the 2 divided by 100, times that by 30, and we get 0.6. That's going to be your standard deviation. So I could write this instead of plus or minus 2%, it could be plus or minus 0.6. That would be the same thing. Okay, D. Also a little bit of work on this one. We want to know the distance between these two just halfway. So if I'm thinking, here's these two numbers, I want to know how far to get halfway in between those two. It's kind of like average. What we do is subtract and divide by 2, and that gives us half the distance between the two. Let me write it right here. So on D, do this as an absolute value. You're going to have the 28.7 minus, I'm subtracting, I want to know the distance between these two, 28.9 divided by 2. That tells me half the distance between these two, and that's going to give me a 0.1. So D is going to be a 0.1. Okay, now you just look at those 4 numbers. The smallest one is the most precise. That tells us that their data points were the closest together. So we've got 1.2, 0.6, 0.1. That is going to be, oh, also D. Okay, this is also our most precise. And whew, so much work. There it is, correct. Wonderful. Good job on this. So not joking. Again, I would pull this up on your phone, have your problem on your computer screen, and you do each type with me as I do it, okay? And you're just going to have to do that 3 to 5 times and you're finished. Good job. I'm so, so proud of your hard work. Have a great day.